Hello everyone, this is Martha from the Academic Support Center once again, and this is a follow-up video where we're going to be talking about properties of logs. Just a short introduction, there will be another section entirely devoted to more properties, but this is just kind of, to kick off the fun, to get started. So we're going to be talking about general properties, the common logs that we encounter, and then the natural log. So some general properties are one, where if we've got log with some base times 1, that is going to equal 0. And so this, the kind of the reasoning behind it is that if we've got our 0 as our exponent, any base, anything raised to the 0 power is always going to equal 1. And so that's kind of why that property makes sense. The second is a little bit similar. If we have a log with some base, and that same base here, the exponent or the answer, it's always going to equal 1. So, and that's because when we have any base raised to itself just once, it's the base. And so for this one, if I had log base 7, I know that my answer for that one is going to equal 1. Now the next two properties are known as the inverse properties. And I kind of like to think about, it's a really, really old song, but it's the electric slide. And you go reverse, reverse, and you just kind of end up at the same place where you started. And that's what these exponent or these inverse properties do. We've got some log with a base. In this instance, our base can be any number, positive number, right? Log base b, and then I've got b to the x. My outcome for that is that equals x. That's that reverse going on right now, right there. You're just kind of back where you started. And also we can have a base, but our log is in the exponent. So our base, some base, raised to the log with that same base of x. Again, we've got that reverse going on, and it's just x. Now these properties are general properties. In this instance, our b can be any positive number, right? Well, there are some common ones that we run into. The most common, well, one of the most common, is it's a common log, and it's log base 10. And most of the time, we just write log because it's a little easier. And so for this, log, the first one, log, we've got that base 10 that we don't always write. 1, that's going to equal 0 because 10 to 0 equals 1. The second property that we've got is that log 10 equals 1. And that's because we've got that, it's not written, but 10 is the base of this log, and then 10, so 10 to the first equals 10, because what's outside is our exponent. And we're going to go into the inverse properties here. We've got log and then 10 to the x. That's just going to equal x because it's not written, but the common log with the base 10, we have the base is the same as what's out here and then the exponent. So now let's see what it looks like in where we've got the base and our log is in our exponent. So this one would be 10 log x. And that just equals x. Now the natural log is one that's kind of fun. There's a special number that we see in nature, and it's so useful, and it's Euler's number, and it's represented with an e. The natural log is the logarithmic function with the base e, and we typically write it ln. And log base e equals ln, but it's just a little bit easier to write ln and a little bit more clear. So how do these properties hold up with natural logs? We've got the first ln of 1, that's going to equal 0, which is also helpful for graphing. Now, The second, because that's where our base matches what we've got, that's ln of e, that's going to equal 1. And just like with our other inverse properties, we've got that the natural log of e to the x, that equals x. And then the last inverse property is e raised to ln of x, that's just going to equal x. So these are some patterns that are helpful to keep in mind. And it may not seem that exciting, but the natural log is used a lot in life. We see it modeled in nature, and that means it's valuable for us. We can use it to predict what's happening or better understand the world around us. And these, again, are just patterns of general properties that we can apply when we're trying to solve problems. So just quick review, if we have a log base and then 1, it's always 0 because the base raised to 0 exponent is always 1. If we've got a log with the same base as the number in front, that's going to equal 1. And we have those two inverse properties where we've got that reverse. Some people think of it as canceling it out, but we're just starting from that same point. And those properties hold for general any base, for the common log with base 10, and for the natural log where we've got base e. Our next video is going to be about graphing these fun things.